Well, good morning, everyone. I hope you've had a good day so far. In our time together today, we are going to continue in this discussion titled Introduction to ABAP. My expectation is that during our time together today, we will together create our first ABAP program for this semester. You perhaps have noticed in D2L that there is a reference to your first homework assignment, that being due this Saturday by 11:59 p.m. Assuming we get through everything we need to today, that will be when that is due, and that homework assignment will be available to you shortly after class today. The homework assignment is a pretty prescriptive walkthrough on creating your first extremely short, that is one line, ABAP program, but working through the process of getting your account set up, as well as working through some of the things that we will talk about today. So I hope you've had a good middle part of the week and are wide awake this morning for our exciting journey into the land of ABAP. We left off at a good transition point last time, talking about some of the basics of ABAP. Today we'll get into a little bit more of the technical dimension of this. Now, some of you, depending upon what other courses you've taken, and we had a discussion a moment ago about how some of you have taken the information systems implementation, you may have already seen this particular concept. There is an SAP product, SAP technology called SAP Netweaver that is very, very important to us in the domain of development and working with the SAP ecosystem. SAP Netweaver, you could think of it as being similar to an operating system, although it is not an operating system in that it sits on top of the operating system. But what you essentially have is an environment where SAP Netweaver provides the technical foundation for all SAP applications. And really the biggest thing that it does for us is provides internal connectivity between the various systems in our given company's infrastructure. So you'll notice, for example, this diagram here on the right side of the slide, which is often referred to as the Netweaver fridge, because it kind of resembles a refrigerator with different drawers in it and such. But what we have here is four different pieces to the functionality of SAP Netweaver, and what's of most importance to us is probably these bottom two pieces down here, and then what you see here off to the right. What will actually happen in an organization that's going to be running SAP products is the first software they will install will likely be SAP Netweaver. And then what they will do is configure Netweaver to connect to other systems they might have in their organizations. You can see here a reference to IBM WebSphere, Microsoft.NET, or just ... in reference to any number of other applications. And this is, in this product, you would go in and specify network paths to various systems. You would put in authorizations for various systems, and you would begin building the foundation of your overall infrastructure. Then, as you install the various SAP programs you're going to run, ERP, CRM, SCM, or whatever have you, you install that on top of Netweaver, and Netweaver then inherently enables those programs to communicate and interconnect with one another. Now, we made reference very briefly in our time on Monday about how SAP, ERP, and ABAP was database and operating system agnostic, meaning that pretty much any contemporary operating system you can run these products on, if we're talking server class, of course, operating system, and it supports a wide variety of databases. What you do is when you set up Netweaver, you configure it to let it know what kind of operating system you're running on, what database system you're connecting to, and it then provides an abstraction layer between all of the different program resources and the underlying technology. So for example, you might be running IBM DB2 as your underlying database, so you would configure that in NetWeaver, and then that's the last time you really would have to worry about that degree of specificity. So NetWeaver is a very, very important product for us in that it handles a lot of the very important housekeeping essential for development. It makes it very, very easy for all of these systems to integrate and communicate with one another, and it also provides a framework for development. Now you'll notice down here in this lower bin of our NetWeaver fridge, this reference to J2EE and ABAP. Of course, J2EE, I trust you recognize that's a reference to Java. So what's the deal here? We see a reference to Java and we see a reference to ABAP. Well, companies can run either what is called a single stack installation or single stack implementation or a dual stack installation. If you run a single stack installation, you can delete the J2EE reference here. You can delete the Java reference, and you would do all of your development as an organization in the ABAP language as it relates to NetWeaver. With a dual stack installation, you can actually write Java programs that would interface with the system in a manner very similar to the way ABAP programs relate to the system. Yes, sir?
Would there be any, I guess, gain to writing in Java as opposed to ABAP, or is it just kind of personal?
Let me, and I'll answer that question by way of giving you the background of it. When SAP came to the United States and started trying to sell their product, ABAP was already in existence, and that was the environment upon which everything was created. American companies said to SAP, we would like to buy your product, but we have an abundance of Java developers, and we have nobody that knows ABAP. Can you help us out? And so SAP created this idea of the dual stack installation. Now, as to the issue of advantage, if they're being candid with you, SAP will tell you the only reason we added Java was because of customer demand. And the reality is, you can do anything and everything with ABAP, but there's a lot of stuff that you cannot do with Java because they just didn't implement the functionality for it, or they purposely limited the power of it. So those organizations that use Java in this context would typically only be using it for interface creation. And it would be very common to have a Java front end tied to an ABAP back end. And in fact, because of that, a lot of companies just say, we're not going to mess around with Java in this environment, and they just do a single stack implementation to keep it easier for them to manage. But the whole reason why Java is even a part of this is just because of pressure that SAP got from their customers. But that's almost a legacy artifact because that goes back, well over a decade when that was put in. So we will be using NetWeaver a lot this semester, although you won't necessarily ever log into NetWeaver or interact with it in a way that you necessarily know you're interacting with NetWeaver. But anytime you query a database or connect to another system, realize that all of that is being managed by the underlying functionality that comes to us through NetWeaver. You perhaps should know from things that you have talked about in other classes that SAP ERP and really all of the products that make up the SAP Business Suite are three-tiered architecture. You have the presentation layer, which is what the end user interacts with. You can see I have a screenshot of the SAP GUI there on the upper left, and then here on the upper right is a product that it exists, but it is so not marketed anymore that it might as well not exist. This is SAP Enterprise Portal. It's a web environment similar to Microsoft SharePoint or other things of that sort, but it's a product marketed by SAP. The reason for including it is that and others would be examples of other ways that end users could interact with our system. But the software that touches the end user is the presentation layer. The presentation layer will interact on the back end with the SAP application layer. And this application layer, application server, is where the core functionality of the business logic and how the system behaves is actually implemented. But the underlying persistence, the underlying storage, does not happen in the application layer. It happens in the database layer. And this goes back to what I was referencing a moment ago. Thanks to the way the application layer and various modules that run on the application layer were engineered, this database layer can be and should be thought of as being database agnostic. You as a developer don't really need to know what the underlying database is in order to write your ABAP programs. Now, that changes a little bit if the underlying database is SAP HANA, because then you're going to pick up some additional tools. And of course, since SAP HANA is an SAP product, they're going to put functionality into the application layer to allow you to take advantage of that may not be available to other companies' products. It's a pretty widely known industry, what's the term for it, piece of news, that Oracle and SAP pretty much hate each other. But they coexist because for a long time, Oracle was one of the major database platforms that companies would run. And so a company would go out and license SAP ERP, and then they'd license Oracle to run it on. So it was kind of like SAP and Oracle were partners in that their products were commonly sold and used together, but there was a lot of animosity there. And so it's thought by some that the big reason why SAP was eager to bring a competitive database product to the market was because of their hatred of Oracle and to give companies an alternative. So we have this three-tiered architecture. Now, what does this mean in terms of ABAP development? Well, I mentioned this last time. You will actually write your ABAP program in the SAP GUI. So if you think of it from that perspective, the presentation layer is where you do your ABAP programming. And then, of course, end users or others in the organization are going to run or use your ABAP programs, and they're going to use the SAP GUI, the presentation layer, for both input and output. So the presentation layer is very important to us in that regard because we use it not only for development but for the interface to the end user. The application layer, though, is where our program actually runs. If you will, if you want a metaphor comparison to another environment, it would be like a dynamic web application where the server dynamically renders a web page and then sends it to the end user's browser for display. That's the idea here. Your ABAP program will run on the application layer, but then communicate with the presentation layer for input and output. The database layer is very important to us. There's one obvious way in which the database layer is important, and that is if we go out and pull information out of the database, or we put information into the database. So data storage is a very important part of a database the database layer in this overall architecture. But there's another reason why the database layer is important, and that's because every ABAP program is actually stored in the database. So this is kind of an odd thing. There is actually a database table, and SAP keeps it hidden pretty well, so I don't know that we could go and find it. But there is actually a database table in the system that has all of the ABAP programs in it. And that's how programs are actually stored for the sake of running the system. So if you think about it, and I don't know that I've ever asked this question before, but if I were to say true or false, every ABAP program interacts with the database layer, that would be true. And you might be tempted to think, well, no, my program doesn't query a database or anything like that. Well, while that may be true, your program is stored in the database and going to be pulled out of the database when the time comes for it to be run. I don't know if you have ever experienced this before. It sometimes happens when you have a new instance of an ERP system and you're one of the first users. So you might have seen this hypothetically in the context of ERP SIM, but sometimes the first time you run a transaction, it takes a while for the system to actually run that transaction. And it's because if it has not had to run that before, it might be pulling it out of the database layer, integrating it into the system, doing the ABAP equivalent of compiling it, and then actually running it. But all of our persistence comes from this connection to the database layer. So let's walk through the logistics of this, and I've changed my diagram here to be vertical instead of horizontal, just to make all of this fit. So here's what happens. An end user sits down, and either by navigating through the easy access hierarchy menu or by typing something into the transaction code box, the user runs a transaction, or what you have called to this point a transaction, but we now understand is actually an ABAP program. That will result in them typing that in or them double-clicking it. That will result, of course, in communication being sent back to the application layer, and the application layer will retrieve the appropriate ABAP program. And you'll get to do this for your first homework assignment. You're going to write a very simple program and install it as a transaction in the system so that another user in the system could just type your transaction code and your program will run. So you'll see how that works. So when the end user runs a transaction, that of course tells the application layer, okay, we need to run this particular program. So the application layer goes to the database layer into a location called the program repository, and it fetches that program. And then it pulls it into the application layer, and so now we're going to turn our attention to this ABAP program. And of course, an ABAP program, like any program you would write, is just a set of logic, a set of control flow, conditional logic, other statements in the language. And so maybe the first thing that happens is when this program runs, it paints a screen for the end user to ask him or her to type information in. You know, you can think of any number of transactions you have run before. Let's think of price change. You key in VK32 because you want to change the price of a product. That results in that program being retrieved, gets loaded up in the application layer, and the end user is given a screen in which to enter prices and product codes and other things of that sort. Ultimately, yes, ma'am.
So the book talked heavily about how there's like no direct interaction between the presentation layer and the database layer.
That is right.
So is there a program inside of the application layer that takes the written code and then enters it into the database so that it doesn't have to directly touch the database? The presentation layer, that is, doesn't have to directly touch the database layer?
Okay, I want to make sure. So the ABAP program all ABAP programs are stored in this program repository. So, as an example of exactly what you're talking about, when the end user says, I want to run transaction VK32, that does not result in that message being sent directly to the database layer. What happens is actually the application layer gets that message and says, okay, VK32 is actually this particular program. And it goes and retrieves it and pulls it in here to the application layer. So you're absolutely right. At no point does the presentation layer ever directly interact with the database layer. But one of the things that we frequently write our programs to do is to accomplish that connectivity through the logic of a program. And let me give you an example. Maybe in our company we sell products, and we frequently have salespeople go in and give customer pricing discounts. And we want to make it a rule in our configuration that salespeople cannot give more than a 10% discount. Well, if we allowed a salesperson to log directly into the database, there is a database table that contains our prices. And so the salesperson or even a system administrator could do an SQL update statement and change the price of a new car to 25 cents to sell it to his or her friend at that price. So we don't ever let anybody, and that's a key statement I'm about to make, we don't let anybody directly touch the database layer. The only way you're touching the database layer is by going through the application layer. And if you tried to change the price of a new car to 25 cents, the application layer would say, no, you're crazy, you don't have the authority to do that, and it blocks that interaction. So when you get down to it, the core of the ERP system, the core to the functionality, is what happens here on the application layer, because that's where all of our business processes, that's where all of our business logic and rules are embedded. Does that make sense?
Yes.
Does that answer your question?
Mostly.
Okay. All right, so as we keep going, if it doesn't fill in the blanks, we'll keep going here. So in my example, I think we were talking about price changes. So the program paints a screen on the end user's presentation layer for them to provide new prices. And so the user will hit maybe the save button, maybe the enter button, maybe the execute button, which will result in information being sent back to our ABAP program. And typically, we will capture that data into variables. Just like in any other program that you write, we're going to have variables that are going to have values set to them. And maybe, depending upon the control flow of this particular program, that is going to result in us going to a database table, 5 database tables, whatever we need to, and inserting or updating or deleting or just referencing information in various database tables. So we're going to be sending messages, sending requests to the underlying database, and then pulling that result set back into the logic of our program, which of course will likely result in the user seeing something on their screen. And in fact, depending upon the flow of this particular program now, we might iterate here, because the user might be able to type in more stuff, and then we repeat this interaction with the database. But ultimately, at some point, the program or the transaction will be over, and there'll be, a wrap-up of any database-related work that needs to happen, and then probably a final screen sent to the end user that confirms that the work was done or otherwise signals the end of the process. So this is the interaction that is very, very common for ABAP programs, and it illustrates, I think, quite nicely the interaction between the presentation layer, the application layer, and the database layer. Now let's talk about the significance of this in the contemporary environment. we talked about the role of the SAP GUI as being the presentation layer. Well, suppose we're looking at a more contemporary installation in a company and they're using, let's say, mobile devices. Is there any reason why the presentation layer can't be an app on a mobile device? And the answer to that is no. As long as it can communicate with the application layer, and the application layer in turn can communicate back with it, we can replace this presentation layer with any number of different kinds of methods of output. And depending upon how our program was architected, it could work just fine. This would be kind of the equivalent, although it's not exactly the same, of in a web context, an end user using Firefox versus Opera versus Chrome versus IE or whatever have you. We don't really care that much about the presentation layer as long as it interacts with us in the manner which we expect. Yes, sir?
Does the application layer run on the user's machine?
No. The application, well, the database layer and the application layer are both server instances that in most companies will be a system unto themselves. And in fact, in some companies, depending upon the traffic, these will be load balanced and there'll be multiple machines that are application servers and database servers. In our environment, however, because we're in a university setting and nobody's actually running this for business purposes, we are running in a virtualized environment, and these are two logically different machines, but they're sitting on the same piece of hardware. Yes, sir?
The communication between presentation and application, I assume HTTP, is there
it can be a variety of different things.
There's no questions about WebSockets.
Okay.
You have you said iterations. Could there be like a consistent connection between the presentation and application?
You can have persistent or non-persistent communication. And this is one of these things that, you know, of course, as new technology comes around, it changes the opportunity for how this communication takes place. You know, you have everything from just very, very basic message packing through protocols such as HTTP to much more robust connections that would incorporate persistence and encryption and all kinds of other security measures and new things being created all the time. You know, probably not a year goes by that SAP doesn't say, now you can interact with our system using OData or using whatever, and they'll add that to the repertoire of the way that the communication can take place. But typically, all of that is going to be controlled and managed by the application layer. Good questions. Other questions?
Whenever a program is wrote, does it and stored in the database layer also go through the application layer whenever it's wrote?
It runs on the application layer. So if we think of this in terms of it being different machines, the application layer is going to send a message to the database layer saying, give me this program, and the database layer will send it the program, and then it will be run on the application layer.
So
When we write programs, we write them on the presentation layer, and so is it then sent through the application layer to the database layer?
Yep.
Even when
Which is why you want to be sure as you're programming, you save regularly, because the save is what's going to cause it to populate back to being stored in the database layer. You know, if you write a 100-line program and never once hit save, and your machine crashes, it's gone. Because there's no, you know, you have not at that point committed it to the database layer. But, and we'll talk about the significance of this perhaps more as the semester goes on, but the rule of thumb that you will almost, and I would say you never violate this, but there are some exceptions. But interacting directly with the database layer is something that is almost never done. And in the instances when it is done in a very, very controlled and constrained manner. Meaning you can't just do anything you want. And to explain why that is, a lot of this partly has to do with good computer science and good programming practice, but the reality is another reason why this has to be this way is because of the law. And I don't know if you've ever thought about the law having any impact on your life as a computing person. But the fact is, we have legislation now that says that if companies present fraudulent financial documentation, people can go to jail. So, if I'm the CFO in a company, and I don't like the fact that our profits are lower than I expected, I could make a good friend of someone that works in my company's IT department and say, hey, go in and update some of the information in the database tables to make our financials look more favorable. You know, basically move stuff from over here and put it over here and hide it. Well, that's a recipe for somebody or somebody's going to jail. So the protection for that is SAP and other companies have engineered their systems such that you cannot touch this database layer directly for the sake of manipulation. And in fact, there are various controls and various what are called seals on the database that will be triggered if you try and do something like that. The equivalent would be, have you ever seen semi-trucks driving down the highway and on their back door they have like these little teeny tiny metal clips on them where the padlock is? That's not designed to keep someone from opening the back of that. You know, any like fifth grader could probably rip that off of there. But what that's done, the reason why that's there is if that does become disrupted, it signals to everybody, hey, somebody's been in the back of this truck, something's off here. Well, hidden all throughout the system are seals on various database things. And when your company gets audited, there are transactions that auditors can run that will check all of those seals. And if it comes back and says, hey, the seal was violated on such and such a table, somebody's in trouble. Because that is a key part of the integrity of the system. So that's why the only way we interact with the database layer is through the presentation layer. Because then it becomes auditable and employs appropriate financial accounting constructs and otherwise. Other questions? You'll read about some of this in your book, I'm sure, as well, and so it can give you some additional coverage of this to go with what we've talked about. Last time we talked about the fact that we're writing programs in a little bit of a different kind of situation than you have experienced perhaps before, in that you're working in an environment where there's already a lot of stuff there, some of which you'll use, some of which you won't, but we have to make sure that we don't disrupt anything. You know, we might have a very, very critical system table that has a really, really cryptic name to it, MDA 74, and that's a database table. What we don't want to have happen is we don't want to have somebody write a program that deletes everything in that database table. That could be really, really, really bad. So we have to be very careful to realize as we create our program, we can't inadvertently collide with anything else that might be in the system. Name collision. Either with other users' work, you decide to create a program called My First Program, and someone else in the class decides to create a program called My First Program. Guess what? One of yours work is going to wipe out the other ones. So we have to take care to make sure that we do not have name collision, which is why we will practice what every company that runs SAP practices follows, which is having naming conventions for things. And each of you, when you develop things, will tag your development with your username, because that way we know everyone's work can be separate and distinct. Same thing that most companies will do in these kinds of environments. Beyond this, SAP wants to protect the integrity of their system because they don't want to get phone calls to their help desk where somebody says, hey, we hired a new developer and he wasn't paying real close attention and he just deleted all our payroll records. Can you help us? You know, they want to cut down on at least those kinds of calls. So here's what SAP says. When you create programs, you cannot begin your program with anything that starts with the letters A through X. So to name a program, my first program will be rejected by the system because the first letter in my first program is M, and M is a letter that falls between A through X. So the universal rule that SAP has employed is you can only create programs that start with the letters Y and Z. So that will keep you from colliding with all of the SAP developed things. They basically have said, we're going to take 24 letters of the alphabet, we will give you 2. Now, how do companies manage this? I know some companies that have said, we have some staff developers and then we outsource a lot of programming. And so everything developed in-house will start with the letter Y, and everything that we have had developed by an external organization will start with the letter Z. Other companies say, we'll just always use Z. You know, there's all kinds of different ways that companies could elect to do this, but this issue of namespace is very, very important. Now, realize that a system administrator can go in and basically say, this system is not one that you can program on, or not one that is modifiable, and basically make the system not changeable by developers. Obviously, in our system, we don't have to worry about that. Our system has been set up for development. I'll just show you this. The actual transaction for this is SCC4. And SCC4 is kind of interesting because it shows us all the different clients that are actually running on this particular application server. And here we are right here. We're client number 413. But you can see there are other systems that have been allocated for other universities or just for future expansion. And we could look at the details of the basics of how our system is enabled here. And you'll just notice there's reference here to changes allowed, changes without automatic recording. So this system has been set up to allow us to go in and do programming. But all a system administrator would have to do is go to this particular transaction, and he or she could turn off the ability for anyone to do development in the system. As we talked about last time, whether or not an individual user can develop is based on their username and whether or not they have been issued what's called the developer key. And we'll see that hopefully here in a few moments in action when we create our first program. How do you get these keys? Well, these keys are actually generated by SAP for your particular system, and you may actually have to pay for them. You know, it would not be unusual for SAP to have a contract with a company that says we will give you 100 developer keys, but if you need more than 100, you'll have to pay for them. But there will be someone in your organization that is responsible for generating generating developer keys and giving them to people that should have them. Any questions about that? Okay, so let's talk about, and what I don't want you to do is don't get what we're about to talk about confused with what we have been talking about, which is presentation layer, application layer, and database layer. In a typical company SAP landscape, they will have multiple application servers. You will typically have a development application server where your developers do all of their programming. This is commonly referred to as a dev system because we use three-letter abbreviations for these systems. And so a company will typically have one development system unless they have a lot of developers, and this is where all of the programmers do all of their work. Then we have a separate testing or quality assurance system. Why is it important that the testing system and the development system be independent of one another?
If it doesn't work.
What's that?
If it doesn't work, you don't want it. Is that what you're...
Well, let me change my question a little bit. We have a development system, we have a testing system, and we have a production system. Why is it important that those be three separate systems? And I think your point was you don't want something that doesn't work being put on the production system. So the reason why we keep the production system segregated from development and testing is so that only stuff that we have really great confidence works goes onto the production system. But my question to you is, if we follow the pattern where we have a development system, and then from there we move programs to the testing system, and then we move things from the testing system to the production system, why is it important that the development system and the testing system be separate from one another?
Because you want your development one to have not as much like production data and stuff, and the testing data is more, or the testing one has more of the production. It's more similar to production than development.
Okay, so the issue of data is really important here. Let me give you an example. You might be called upon in your organization to write a transaction that does payroll manipulation. And even though some companies may be very transparent in their operation, most companies get really, really sensitive when you start talking about how much people actually make. And so your production system actually has to have real payroll information in it because it has to keep track of how much people should get paid and transfer money appropriately and so on. But you might not want real payroll information to be in the development system because then anybody with access to the development system can hypothetically get at that and see what everybody in the organization makes. So sometimes the difference between these systems is in what the underlying data is. The production system obviously has to have contemporary, live, up to the second information on company operations. But when I'm developing a program, the data I'm manipulating might be not as current. And that's not really going to change the logic of my program. So that could be one reason why we see a difference here. Another reason why we see a difference here is there's going to be, by virtue of the fact that we have a shared development environment, a lot of junk that gets built up in the development system over time. And the danger we run is we might write a program called Z2. And in our program, we reference a module called Z44 that was written by one of our colleagues. And everything works great in the development environment because I just finished this program on Tuesday, and this developer over here finished Z44 on Monday, and so everything works great in development. But we're ready to put my program into production, but this isn't going to go into production until a month from now. So there's a danger here that I might think that my program works because when I test it on the development system, it works great. But the reason why it works is because it has dependencies to things that aren't actually a part of the production environment yet. So the virtue of this idea of multiple landscapes is we create everything in a development system, which is kind of a free-for-all environment. But then once we think we're done, we move our program to a testing system, the QAS system, that mirrors the production environment as close as we can make it.
and we test to see if it works. Now the reason here is obvious. If it doesn't work, all that's happened is we've disrupted our testing system. But if we move it directly into production and it doesn't work, we have a big problem on our hands. So what companies will do is they will create on a development system. When they think their development is done, they'll move the code base to the testing system, test it there, and if it passes testing, then and only then will they move it to production. There's a fourth instance referenced up there, which is training, which is pretty obvious. This would be a system that we might use for employee training, for development training. A lot of companies won't have a training system, but training system is, not live data in a lot of instances, just a place for employees to go to try something out, or for us to use to train new salespeople or whatever have you. Yes, ma'am.
Okay, so the testing environment is mirroring as close as possible the production environment. Does that mean that there's a separate database that you mirror when you build the testing?
It could. It absolutely could.
Because you don't want to obviously change the database, but if your program is changing database information.
Absolutely.
And then do you write some sort of configuration manager or something to compare the two databases to see where they diverge so you can see in the testing environment if it's working or not, or how do you validate?
That's a harder issue that there might be some tools out there, and there probably are some third-party tools out there to help with that. But normally, what you have just described is something that falls to the system administrator to make sure that the environments are being properly maintained and kept current in a way that's useful. And so what will often happen is periodically a company will take their production system and copy it back to and make it the development system. Periodically they'll do that just to clean out all the old garbage. They'll give people advance notice, hey, bundle your stuff up and whatever have you. And so then you have that kind of periodic flushing of old stuff and new stuff. But when that's not done, as soon as you do that and then time passes, the systems begin to diverge. And that's where the system administrators really have to work with the other people in the organization to keep all of the systems as close to parallel with each other as they can. And in fact, things like the cloud and virtualization really help with that, because you could clone a server and put it up in the cloud. And then you have a perfect copy, at least as of a particular instance in time. But if you think about it, for a large company, a production system is probably taking data in or changing data 24 hours a day, 7 days a week. I mean, it's an incredibly dynamic environment. So you've got to figure out when you want to take that snapshot and move it over for use in your development system, for example. So, and I think what we'll talk about as we go along here will further clarify this. So everything we do in ABAP development is done understanding that our program is eventually going to move to other systems. So SAP architected the development process to force us to work in that fashion. And so we have what are called system transports, which I like to think of as like little barges or boats. And so what happens here is whenever we develop something, we put it in a transport. We put it in my picture here, we put it in this particular barge. And the benefit of that is at some point I'm going to say, hey, I think my barge is ready to move from development to testing. And so my barge of code will move from one system to the other system and be installed there. So anytime we develop something, we put it in these transports. But beyond that, we have, development is done within, and here's another term I didn't bold this, but packages. So you'll see here in a few moments, we create a package which, if you will, would be like a giant box or a pallet or something like that. And we put one or more programs in these packages, and then we put packages in a transport. Now, if you think about this, the virtue of this system is this transport here could be Project, I think I spelled this wrong, Project Apollo. You know, we have multiple developers working on Project Apollo. So we create a transport for Project Apollo. And we tell all of our developers, when you're doing your work, create a package, put all your Project Apollo stuff in that package, and put that package on this transport. And so when we're done with this project, or think we're done, and we're now ready to test it, we will transport this transport from development to quality assurance, and all of the code that's a part of Project Apollo will move to that other system. And only the code that is a part of this transport will move. There are all kinds of virtues to this structure, because if we transport this to the testing system, and as is not uncommon, within 15 minutes of doing so, we discover something is broken, we transport it back to development, and it was just like it was never there. So one of the roles of a system administrator is to manage these transports into and out of a system. This is also how SAP will deliver certain kinds of service packs and updates. They'll give you a transport, you transport it into your system, you verify the integrity of it, you make sure everything is working fine, and then you commit it. But you transport it in, and you don't like something about it, it seems like something's not working, you want to do additional testing, you back the transport out. That's what a system administrator will do. Yes, sir?
When a program is transported from one machine to the next, does that mean that it is no longer present on the previous machine?
Depends on how you have specified and what your system administrator does. But normally it would still be present on the old machine. You will actually do a transport for your first homework. And what you're going to see is you're going to create a package, put your program in it, put it in a transport it, and then try and open up your program again. And basically the system's going to say, I'm not sitting in a transport anymore. You need to create a transport for me on this system. And so you have the ability to basically pull it from one system and put it in another system, or you have the ability to basically copy it to the new system and leave the old one still there. And there are transport management, you know, we talked about SAP classes. You can take an entire multiple day class on all the things related to transport management. This is a big job that your system administrators are going to be responsible for in your organization.
So if you're a project manager, you would like map out what's going to go on your barge, right? And then you'd ensure it's there before you ship it. So that's how you mitigate the 22,244 issue.
You got it. You got it. Absolutely. And it gives you a way to solve it if you made a mistake and missed something. So, you know, just to tie this to a picture, so, you know, I might be over here working on an SAP system client on our system this semester, 413. It's a development system. I do all of my programming. I think I'm ready to move it along, and so I move it to our quality assurance system. Or really, I request a system administrator move it to the quality assurance system, and then probably other people in my organization test this. And when they are convinced that everything is good, and they're prepared to give it a thumbs up, then they will authorize it to be transported into production. Now, the great thing about this transport system, and sometimes this happens, works great in development, move it to quality assurance, and quality assurance and production should be as close to the same as we can make them, and it works great on quality assurance, and we transport it into production and something breaks. hopefully not a frequent occurrence in our organization, but does happen. And that's the virtue of this transport system. A few key clicks, and the system administrator can pull that transport out of there, and we haven't disrupted the system as a whole. Here's the training system, which you can see, the training system isn't really a part of this whole transport architecture. And what most companies will do with the training system is just periodically they'll copy one of these systems down to the training system. But this is essentially a sandbox environment that's just there for, as the name implies, training. So any questions about this?
When you're developing in the development environment, you're all using the same server. So is there, like SAP have locks, for transactions and stuff? Do they have locks for coding on certain stuff? So if I'm making a change to 22, you can't make a change to 22? Okay.
And in fact, we won't use it, and it's not as fully developed as I think it will be over time, but SAP has begun to realize the value of things like Git and other things like that, and incorporate that into their development process as well.
So you can branch. Okay.
Yep. So, programming process. First thing we do is we create a new package, the equivalent of create a new big box, okay? Or if we have an existing package already, we just say, I want to use that existing one. So we either create a new package or we select an existing one. We create a new or select an existing transport. So packages live in transports, which remember the transport is my metaphor here of like a ship that travels.
Like a cargo ship.
Yes. So we create a new package. We put that package in either a new or existing transport request, and then we start creating our program. The first time we create a program on the system, we will be asked to put in our developer key. You only have to do this once, and then the system will remember it. It's kind of like entering a license key for a software product. So you put that in the one time that you do your first development, and then, it's kind of funny, I reduced this to 1 point here, like this is not a big deal. Then you just create and debug your program. I mean, that could be 6 months of work, but that's the next step here. And then, of course, you should do some testing on your own, and you should do some debugging. And as a part of this, and we'll talk about the significance of this as we go along, we activate the program. And then ultimately, when we're done, this can now be transport, our finished package, and any other things that are a part of our transport to another system. As an aside, if you're creating a program that you know will not be transported, you can assign it to an existing package in the system called $TMB. We won't do that. You won't typically do that in an organization, but if you wanted to, if you had need for creating a program, I don't know, just for the fun of it, that you knew was never ever going to be transported, you could attach it to that instead of another package.
Can you if you're not branching, could you just if somebody else is working on 22, could you just copy 22 into temp and then just work on this just so that you could map the data or transport data?
You still, if it's ultimately a real project that's going to be transported, you wouldn't want it to be in temp. Temp should be used maybe once or twice in your whole career, maybe. It's not a very common thing to use that as part of your development. Now, for your homework, you're going to get to do some transports just to see how it works. And this is the only time we'll do it, is as a part of homework 1. And the reason why we won't do it a lot is we don't have multiple systems. We're in a university environment. We don't have a development and a quality assurance and a production system, but the system administrators at our hosting site have set it up to make it look like you're transporting to another system. But in fact, you're transporting to a null, non-existent system. Okay? But you will get that experience for your homework. And in fact, your homework is to write a program. And so hopefully we can take the next 15 minutes here, and I will very quickly go through and just show you what it is that you are going to be doing for your homework by way of our writing our first program. Let me start here, give you some basic ABAP syntax. ABAP programs are made up as, we have lines of code. Those lines of code, like in other programming languages, are often referred to as statements. But you see a term that's used in ABAP that you don't typically see in other programming languages, which is sentences. So I don't know that I'll use that term a lot, but if you hear an ABAP developer talking about, 85 sentences, that's 85 lines of code. Every ABAP line of code begins with a keyword. It is conventional, and this is different than a lot of programming languages, for all keywords and all code to be in uppercase, except for string literals. Like if you want to display hello world, you might not want hello and world to be written in all capital letters, so there you would have mixed case. But the keywords in the language are by convention in all uppercase letters. Unlike some programming languages that end every line of code with a semicolon, every ABAP sentence ends in a period. Statements can be indented as desired. We will have a coding format that we will use, but unlike some programming languages, for the most part, the column that you start a line of code in does not matter. Unlike many languages, though, ABAP is spacing sensitive. So here's the thing. We will see this later on. You want to write the ABAP equivalent of x equals 3 plus 4. You have to write that as x space equals space 3 space plus space 4 period. And if any of these spaces are missing, that's a syntax error. So ABAP is going to be very particular about spacing in a way that some programming languages are not sensitive. Statements can extend over multiple lines. If I start a line and in column 1 there's a star, then that line is a comment. So that's one example of generally indenting doesn't matter, but it does matter if you put a star in the very first column, because that is a comment. If you want to put a comment anyplace else, or at the end of a line of code, double quotes are what you use for 2 end-of-line comments. Now, the next few slides in the slide deck walk you through what I'm about to do just in the SAP GUI. Okay, so I'm ready to do some development. There are many different ways you can begin writing an SAP ABAP program, but the most common way is to run transaction SE80, which will bring you to the ABAP workbench. Now, you might see in some of my screenshots in various labs or homeworks or other things, there being a picture here. For some reason, the new system that our hosting environment has created has no picture here. We just have this glorious white screen here that says, welcome to the ABAP workbench. But this is where I go when I am wanting to create a program. The very first thing I have to do is turn my attention to the creation of a package. So here on the left side of the screen, in something called Repository Browser, we have a drop-down box that will allow us to choose package. And so we make that selection, and then in the box underneath it, I can search for or just type freehand the name of the package that I want to reference. Now, you will see this in your homework. Our coding convention will be to begin all of our packages with your username without the dash. So I'm using in our class session ZN001. So I'm going to call this ZN001 PKG01. And once I type that in, I'm going to hit enter. Now at this point the system goes out and looks to see if it can find that package. And in fact it comes back and says package ZN001PKG does not exist. Do you want to create it? And the answer to that is yes. So I click yes, and I now am in the process of creating a package. You might be familiar with the visual cue that any cell that has this square with a check mark in it means I have to put something there. So short description, this I'll just put here, package for ABAP development. And then I will hit the green check mark for continue. Then I get this next screen, prompt for local workbench request. And then this right here, this request, this is now transport. Transports are called transport requests. And so sometimes in the system, you'll see them referred to as a request. If there was an existing transport associated with my project, I could search for it and call it up here. Notice here I have a button called Own Requests that will show me all of my previous transport requests that I've created. But I don't have any right now. So I click on this icon right here, which is Create Request, and then I get a dialog box that wants me to describe this transport request. And so I'll just write test transport request. You know, this is where I'd put Project Apollo or whatever have you, and then I hit the save icon. So, and now you notice it has given me a request number, and I hit check mark, and I have now created a package, I have created a transport, and I have put that package on that transport. Over here on the left in my repository browser is everything that I have, which is nothing but my package. So I right click on that, and once again I'm going pretty quickly because of time, but your lab is going to walk you through this, your homework. I right click and I choose Create Program. And now I have to give my program a name. And because of our issue of avoiding naming conflicts, I will always start my program with my username except the dash. And so I will call this ZN001_hello. We'll talk about top include later. We don't need it. Hit the check mark. And now you are not registered as a developer. Now it wants my developer key. And remember, I said we only have to do this one time. So let me go to classes 4767, lectures, spring 2018, my key. Okay, here's my key. And what I would encourage you to do is what I just did, which is copy and paste this. Make sure you don't get the little apostrophe in there. Continue, and it's going to take it. It took my key, and so now I never have to do that again. And now I can just hit save, and then save again. You do a lot of just acknowledging things in dialog boxes, and then eventually you will be presented with the ABAP Workbench development environment. And this is now where I can create my first program. So I will type write hello world. That is now a syntactically correct, complete ABAP program. I will save my program. I will activate my program, which also does a syntax check. And I will run my program, and there I have a very, very complex program that says hello world. Okay, so that is the development process walked through in very, very express fashion. Okay, so let's look at the slides I have with this. You launch the editor with SE80 is what I would recommend. You can also get in through SE38. You can set a variety of different editor settings either through menu items, and you'll do some of this for your homework, or there's this thing down here, and this is something that I don't really give you directives on. You can kind of set this as you'd like, but here in the bottom right corner there's this, it's hard to see, and it might even be off the edge of your screen. Let me try and fix this. There's this, this guy right here, that if I click on, lets me configure parts of the IDE. So for example, and I'll do this to make it a little bit easier, we'll say that I want normal lines of code to be 18 point instead of what they are. And so you can go in and turn on line numbering and syntax highlighting and all kinds of other things in the environment through this. But this is where you're going to write your ABAP programs. So utility settings will let you do some of that, as well as that icon there in the bottom right. Here's my note about name collision. You're welcome to write as many programs as you want this semester, but make sure that all the development you do, whether it's for official class purposes or just exploration on your own, stick to our naming convention so that you don't inadvertently wipe out someone else's work in the system. So we start SE80, we select package, we put in the name of the package, we get prompted for it to be made. I remind you of our naming convention here on the slide once again. If no transport request exists, we create one like I just did, and here I show you the button clicks associated with that. And then you'll notice in some of my screenshots, and it's just because of how I have my SAP GUI set, you'll notice in the slide I show all of this stuff here, but when we actually look at my SAP GUI, we only see repository browser. That's because I've rolled up some of the stuff here, which is probably the way yours is going to look. But in fact, this, what's called this object navigator, is really powerful for us finding different things in the system, development artifacts, and so on. Program name is always in all caps. And we don't use top include until we talk about when we need it later in the semester. And see if there's anything here that I didn't show. Use the editor to enter code. Obviously, we're going to spend a lot of time in the editor this semester. The editor, you might be thinking, oh, it's kind of crappy that I have to develop in the SAP GUI. It's actually a really cool development environment with code completion and all kinds of other things that would really make your coding to be pretty straightforward. The syntax checker that runs against ABAP programs is bar none the best syntax checker I've seen of any programming language. You know, sometimes you get a message from a compiler that basically says something went wrong, you figure it out. You know, ABAP will say you're missing a period at the end of line 12. You know, that's the difference in the kind of feedback you get, and sometimes it'll direct you to documentation or all kinds of other things. And so then ultimately you'll use direct processing to run. When we get together next week, we'll talk about something that I glossed over today that is actually very important, which is the activation process, but we don't have time to do it justice today. So we'll finish up that. You, later on today, should be by 10 o'clock, you'll see available in D2L Homework 1, which will let you walk through the process that we did. Pay attention to the instructions. You'll take lots of screenshots and fundamentally upload a Word document with lots of screenshots in it as your homework submission.